Hi, everyone. Welcome to Choose Your Dragonwing AI Adventure. I'm David Tischler. I'm a developer relations engineer on the Qualcomm Dragonwing team, newly formed. I'm joined by Heath above me. You want to say hello real quickly, Heath?
Yeah, hi everyone. Good to see you. My name's Heath. I'm on David's team, a developer relations engineer on Qualcomm Dragonwing.
Awesome. Thanks, Heath. And down below me, Ollie, do you want to say hello as well?
Yeah, we'll do that. Thanks, David. I'm Ali Ors. I'm the senior AI software product manager for all our automotive, IoT, industrial, and robotics product lines in business.
Awesome. Thanks, Ali. So, Heath, you and I are going to drop off and we're going to turn this over to Ali to go through a little bit of slideware, some presentation. We're going to return later on to show off some of what Ali has gone through and what he has covered. Now, I will say that we're going to go through a lot of information, several platforms, tools, utilities, frameworks. Don't worry if you don't get everything from this one. We're going to do additional live streams and webinars individually devoted to these topics. But for today, we thought it would be nice to give a high-level overview, that 30,000-foot perspective of all the different bits and pieces that are in the ecosystem. So with that said, I'll turn it over to you, Ollie. But for anyone watching, don't worry if we don't cover everything that you're looking for. You'll need to click the bell, subscribe, like, comment, whatever it is on your platform of choice, because we will have dedicated topics upcoming for each of these. All right. So with that, Heath, you and I will say goodbye for a little while. We'll be back. And Ollie, it's all yours.
Cheers, David. So, hi everyone again. I'll add to what David said. You can send us in questions live through whatever platform you're on as well, and we'll try to answer as many of them as possible, either in the text or as we walk through it at the end of the demonstrations as well. So jumping right into it, as David laid the groundwork, this is what I'll be going through is an overview of what we recommend from an end-to-end AI development perspective with our tools, what we have. There is a lot of technology. There's a lot of depth to that technology that we're going to be actually presenting today. And we will have follow-on sessions, a series of these where we get into deeper dives into specific components of the overall flow. But where we're focused on with our Dragonwing products, especially from an AI perspective, has a very wide applicability in different verticals and different domains and markets, going from worker assistance in the workplace, but also collaboration in an office setting as well as a factory setting, leveraged in surveillance environments like public safety, law enforcement, traffic control, smart city enablements with AI in the home, smart hubs, smart thermostats, smart everything in the home, really like driving intelligence onto the edge in homes, and getting into our daily lives, deployed in point of sale technologies and in retail, as well as now with robotics and humanoid robotics and drones. These are all domains that the Dragonwing products actually enable a lot of intelligence into. And today we're going to focus on currently on the portfolio. It's an expanding portfolio, but we have two devices and two like kits and products that we're really focusing on and are the cornerstone of enabling the use cases into these different markets in our portfolio. What we call the IQ8 series has up to 40 tops, and we always quote dense tops, so dense integer tops in our numbers. So these are dense tops. Of course, you can get higher performance out of it depending on what you're running. A good mix of CPU performance and GPU as well in the IQ8 series. The IQ9 actually takes this quite further, gets up to 100 tops, that there's two NPUs, 50 tops each, that you can run a lot of AI models in parallel across these NPUs. You have a more capable, larger cluster of high-performance CPU cores, as well as an upgraded GPU on it. And I talk about the NPU, the real AI acceleration, brains in these devices, as well as the CPU and GPU, because they're all backends and compute engines that are available for AI compute. And our enablement software does allow you to map AI models to all of these. And so sometimes the question comes, well, where should I run my AI model? And all of these architectures, so these compute architectures like the CPU, the GPU, and the NPU have different strength points that can be leveraged. The CPU is the fundamental compute engine that runs your application, runs the high-level OS. It's very flexible. You can almost throw anything at it, and you'll be able to run. Now, that high flexibility comes at a cost of sometimes lower performance, so lower throughput in especially workloads that are related to AI aspects, but it has a good amount of resolution and accuracy to it, has floating point support, for example, to achieve that accuracy. So sometimes it's best used in certain low resolution image recognition and detection as a first step, or some voice type of applications, but it's always there as a flexible component in the heterogeneous compute environment, but not always the highest performance that you'll get. The GPU, unlike the CPU, can achieve higher levels of performance and allows for much higher levels of scalability, but that comes at a price of power. So it is very power, I won't say hungry, but it does dissipate a lot more power compared to some of the other options like the CPU and NPU, and that to achieve that higher scale and that higher compute aspect. We find that the most efficient way of running AI models, of course, is the NPU. In our case, the Hexagon NPU, or tensor processor, and this comes because we're now at at our 8th or 9th generation of the NPU. Qualcomm has been developing the Hexagon processor for quite some time, and we've added a lot of technologies that do support all of the newer models like the LLMs and VLMs, but still also has very good performance for computer vision, convolutional neural networks, achieves even certain aspects of image transformation and control, provides a lot of high performance throughput for model compute at a very high power economy to it. So very efficient on power, very high throughput in performance. So the ideal engine to run your AI models is the NPU. And then if you've run out of capacity on the NPU, sometimes look at the GPU, or if you're running something less frequently, you can leverage the CPU as well. So that's the hardware side of our story. And where the adventure really starts in terms of getting, for our developers out there to get your application onto a Dragonwing IQ8 or IQ9 product, is of course the software. The hardware, the software really is what enables that hardware that sits underneath. And today's, this is what we're going to touch on. And as I mentioned, we're going to get into a lot of follow-on discussions and series of presentations and live streams where we talk about each of these components and get even, maybe multiple sessions on some of these components to get into the depth of it, and, get into some specific examples of how you build applications in the various domains. One of our key enablements out there is the Qualcomm AI Hub. And this takes you from, when we look at the full flow of AI development, from collecting data to training and then optimizing your model, converting it, compiling it, and then finally running and integrating into an end flow. The Qualcomm AI Hub covers most of that training and optimization and compilation aspect. And it leverages what's below it, the QAIRT tools, what QAIRT runtime, so Qualcomm AI runtime tools, into converting and quantizing and creating a runtime. And the QAIRT tools, for short, leverage the runtimes. Like we have a proprietary runtime GenX, which we'll touch on today. We also have support for open source, very popular open source runtimes like ONNX runtime and LiteRT, what used to be TensorFlow Lite, LiteRT runtime as well. And we get into also IMSDK, which is a great enablement that we have out there that actually brings it all together and integrates it into an application. And I'll also touch on a Qualcomm company, Edge Impulse, which kind of takes it a step back. Instead of just training and pulling in models, allows you also to collect custom data and create that full flow in a different environment that is very developer friendly, and has a lot of benefits for certain types of applications as you're building in that environment. So to focus on the Qualcomm AI Hub, what this is, sometimes it's seen as, oh, it's just another model repository. Yes, that's a part of it. It is a model repository. It is a gallery of models and metrics, but these have been tested and are ready to run on device. Now this count is probably already out of date because we say 275. I had to put in the plus there because it keeps growing, the number of models that we have for various platforms. And AI Hub is not just for Dragonwing. Other product lines from Qualcomm are also supported. And that's where we have a lot of these pre-built models, very easy to get to and leverage. They're pre-optimized. So all you have to do is like pick your what hardware you're interested in. You can search for a certain application domain or certain model and quickly find what you need and then deploy it onto your hardware. And but it is not just a model repository. We also have the Workbench aspect, so you can actually bring in your own model. So if it's something that we don't have in AI Hub as a model pre-optimized, or if it's something that you built or leveraged an open source model and made variations to it, you can come in with your own model and run inference on a hosted device and iterate on the performance as needed. So we're able to then also provide sample apps within AI Hub. So it's you can leverage sample app codes to match models performance on Qualcomm SoCs. So, and this is also another growing domain. So right now, like over 10 sample apps, and we'll be growing those as well. So very useful way of enabling our developers to bring their AI models on device. You can target a platform, pick a runtime, like QAIRT from our Qualcomm AI stack, or ONNX runtime, or LiteRT, test and validate and deploy straight onto the device as needed. And I do encourage you all to go check it out. It's available, very user-friendly UI to it, and you can leverage the models, work with them, or bring your own model through the Workbench, or bring a model, for example, from Hugging Face into that deployment as needed. Now, what Qualcomm AI Hub uses in the background is what we call the Qualcomm AI runtime tools. So this is where, if you wanted to get a bit more hands-on, if you wanted to go deeper in understanding some of the conversions, some of the optimizations that are happening to the models, or you want to get more into, let's call it manual mode, the QAIRT tools actually allow you to step in deeper if you want to leverage those tools. They're also available to our developers, and they're there to answer questions around, well, does this model compile, and if it doesn't, why doesn't it compile? Like what's going on in the background? Is the accuracy what I expected or what I need for my end product? If it's not acceptable, how do I improve the accuracy? What are some of the switches that I have available to me to work through? Can I, is the latency, is the actual performance throughput, the token throughput, or the inference throughput what I need, or are there other choices that I can make to improve that output, both in terms of the accuracy as well as the latency of the model? And this is where the QAIRT tools will give you additional analysis tools to check your architecture, to check how your quantization is working out, evaluating it, and debugging, analyzing your performance, visualizing it, and then even leveraging a simulator to put it all together. So this is a deeper level tool that we'll have additional sessions on as well. But you have the option. We're not just abstracting this functionality and saying you use AI Hub and you don't see what's behind the curtain. We're also opening the curtain and giving you access to these tools to get deeper into optimizations if you choose to. And then calling out some of the runtimes that the QAIRT tools leverage. I wanted to focus on GenX. Of course, there's ONRX RT, Light RT. There's additional work with Executorch, etc. that's coming up. GenX itself is something that we have in beta right now, so we launched it very recently. And this is where you're able to run some of the latest GenAI models with just a few lines of code. It's super easy to use with our developer, for our developers. It unifies the SDK for NPUs, GPUs, and CPUs. So as I showed previously, the different hardware options that you have from a compute engine on the IQ8 device or the IQ9 Dragonwing devices, you can target any of those computes with GenX. Of course, again, your best performant AI compute engine is usually the NPU. And you can, pick Hugging Face models off of with GGUF format and directly leverage them, or you can pick AI Hub models locally and leverage them with QAIRT. So it's a one-click setup across Windows, Android, or Linux from an OS perspective, or whatever machine you're running on. Offers a very easy-to-use command line interface with Python APIs, and it just is very developer friendly. It takes 2 paths through the device. So with the GenieX SDK, you can almost bring any GGUF model from Hugging Face, run it through the llama.cpp plugin, and get it onto the compute hardware. And that's the fast path of deploying. Or you also have still access to the GenX QAIRT plugin, so the QAIRT runtime SDK path, which gives you the best performance. So you have an option of quickly getting a model up and running, or also leveraging, if there's support in QAIRT, of the highest performance that you can achieve on an NPU, for example. So those are both available in beta right now. We're adding a lot more functionality, and this is available straight from the AI Hub page to you as well. And it's open sourced from our side. Now that covers the training to the runtime aspect, and these are all about, so far has been about AI models and running, picking an AI model and converting it, optimizing it, and getting it into a form to run the model on the device. But of course, the AI models themselves are not the end all be all of what you're building. We're talking about building real applications to be deployed in the real world into specific business cases or specific needs. And that's where the IMSDK comes in. So IMSDK, which stands for the Qualcomm Intelligent Multimedia SDK product, it's about building full applications. So we're not just talking anymore about the AI model itself as a standalone, or did it convert, and how many inferences per second or how many tokens per second am I getting. We're actually talking about building that out into a full application where you have a multimodal multimedia input aspects, as well as sometimes what's called glass to glass, so from camera to display type of flow. And this has been in production and used for production with the Dragonwing chipset so far in building some of these applications that you can see on the screen, like video conference cameras, body cameras, dashboard cameras, patient monitoring appliances, a lot of functionality. And it provides a full flow to create these applications, and it's very user-friendly to pick and choose. It's almost like building a Lego way of approaching your application build. So you have all the aspects of handling, camera capture, the pre-processing that video, the AI inferencing, of course, is part of it. You pick your models of what you're doing with that input from the camera or various sensors. It could be multimodal, and then leveraging the tensor processing getting into an encode and then maybe putting that out on display, or creating an action from machine to human, etc. So all of that flow is covered by IMSDK. And one of the neat features that it has, and in 2 weeks we're going to have an additional session that gets more in depth into this IMSDK component. It's microservices. So we're offering blueprints around containerized blueprints around how to develop and deploy use cases. So you have different containers or microservices available to you to leverage the IMSDK, to leverage, for example, analytics. And if I pick examples of the analytics services that are available, like for example, for Tripwire Analytics, you can actually look at an image and create zones in that image of quickly building an application of what is an acceptable area for a human to be in versus where you want an action to be taken if a human or specific object is across that line that you draw in your video. So this is used in like for cobot applications where you don't want you want the robot speed to reduce or to totally stop moving if there's a human that gets too close to it, so that there's no workplace accidents happening, or there's no issues with accesses. You can leverage it for security zones, like where you don't want unauthorized people in a certain area, and you want that flagged and highlighted. So you can use these region analytics boxes, these people analytics services, or Tripwire Analytics. Similarly, in audio analytics, you can leverage that to, it comes with speech recognition, text-to-speech, and even auto translation services within that analytics container that you can leverage to build out a full application that has audio interaction as well. So this is all about getting to not only focusing on the AI model itself, but getting into the full application flow end to end, and making that experience very easy to pick up and get to a production ready model and application for end developers on the Dragonwing devices. And last piece that I want to touch on is Edge Impulse. This is, again, it's almost like a very, you can see from the chart, it provides a very complete flow of building AI applications on our side. And and that's why it's an end-to-end MLOps platform, machine learning and AI ops platform for model development as well as model deployment. Now, it can ingest a lot of different data inputs, image, but beyond image and audio, also just general time series. So anything that's temperature, vibration, other aspects that are time series type of data signals, it can ingest those, and you can collect your own data and build your custom model from the data that you've collected. And this could be biometrics as well as and the other ones that I mentioned, like temperature, vibration, etc. And it can extract the features and build the model all in the flow and optimize it and deploy it. That's a very good fit for certain types of applications. It's not that good a fit for agentic AI and chatbots yet, or LLMs and text generation. The other tools that we have, both from an AI Hub perspective of models we support, as well as if you want to get into deeper optimization tasks with the QAIRT, QAIRT tools, those are a better fit for that flow. But here, anything that's not safety critical, so not getting into automotive or industrial safety domains, but leveraging it for building out sensor-based deployments, the Edge Impulse flow is very efficient. So what that means is that you can leverage it for things like monitoring machinery for predictive maintenance, monitoring manufacturing lines for anomaly detection, and various signal processing type of use cases. So you can still deploy with Edge Impulse into a lot of different industrial cases, some of the ones that I mentioned at the beginning of this discussion, and you can take it end to end with data collection to model optimization and deployment with it. Of course, we have a session in 2 weeks on the IMSDK. We will have additional sessions in deeper dive. Please, you should definitely join us on those because this has been a very quick deep dive into what we're offering, and We have a lot of content online, of course, but we also will have sessions that we're building out, a lot of examples that can be taken up quickly. And with that, I'm going to hand off to David and Heath to actually show some of this in how it really works, and click on some of these links that actually take you through and help you build on the Dragonwing kits that we have. David, Heath, off to
Yeah,
you.
thank you, Ollie. So you did absolutely cover a lot of ground there. And
Yeah.
like you said, we will do deeper dives into each of these topics, dedicated live streams and webinars in the coming weeks. I think the next one is 2 weeks away, right?
Yes.
And that one, like you said, is going to be devoted strictly to IMSDK. And so that one will cover the GStreamer plugins, the acceleration, the micro container services there. So stay tuned for that one. I am going to start us off with a quick demo. Heath, you'll be up next. I'm going to bring in a video of what I put together actually just yesterday. So let's get that video queued up.
The
And away
Dragonwing
we go.
documentation is a brand new site that we've put up dedicated at the moment to the IQ8 and IQ9, with coming soon documentation for the RB3 Gen 2, IQ6, and the IQX series. But at the moment, we do have the IQ8 and 9 fully loaded, and we have both Qualcomm Linux and Ubuntu documentation in here as well. And this allows you to very quickly choose the device and navigate through to get the device up and running. It'll describe all of the hardware that's included. You can go through the flashing process. It's all laid out right here for you to just go start to finish, everything you need. Let's just take a quick look at Qualcomm Linux while we're here as well. You can dive into the individual pieces like display, Ethernet, graphics, sensors, video, all different bits. Another item that you spoke about was the AI Hub. And the AI Hub is somewhat similar to a Model Zoo, but there is a bit more to it than just that. Inside of the AI Hub, let's take a look at models real quick, just so we can get a sense of what's contained in here. And you have GenAI models, you have traditional computer vision models, you have some pose estimation, you've got segmentation, depth perception, let's see what else is in here, classification, eye gaze, upscaling images. So a lot of ready-to-run models that you can load directly onto your IQ8 or IQ9, as well as some other chipsets as well. I see you're supported here too. Another one that you mentioned along the way was Genie X. And Genie X is a new LLM VLM runtime that makes use of NPU on-device accelerated inference. And it'll allow you to run via QAIRT, QAIRT as we call it, or standard GGUF models. And these are very, very popular in the community. And you can see here, broad coverage, run community GGUF models directly from Hugging Face via llama.cpp. So these GGUF models, what that means is you can come over to Hugging Face, and I've done a search here that I've already narrowed down to GGUF, but all of the major models are then represented in this format. I can see Quen is in here, Minimax is a popular one, brand new just 2 days ago is Muse Glimmer. So you can go through here and find models in this format and run them on device as well. Some of these actually have millions of downloads. IMSDK. You touched on this one as well, Ollie. IMSDK is our GStreamer pipeline creation and plugin platform. IMSDK has also put together brand new documentation. And in fact, I think it's 2 weeks from now, we're going to run a live stream dedicated entirely to IMSDK. So you'll definitely want to catch that one as well. But IMSDK, in their documentation, which is quite simply imsdkdocs.qualcomm.com, they have sample pipelines that are ready to go and sample applications using C++ or Python. I've gone through and run a few of these as well. It's actually really simple. You can just click on one of the applications, and here's face detection, here's semantic segmentation, but each of these has this little drop-down menu, try me, and each of them then goes through the steps that are necessary and an expected output for the application. If I come over to an AI pipeline, such as pose estimation, and I open up Try Me, I can download the models and the label files, copy them onto my device, export a few variables as needed, and they give you the GStreamer command to copy and paste. I've actually done that over here. And let's launch this on an iQ9 that I have on my desk right over here, just a bit out of range from the camera, and I don't want to pull on the cables, but you can see it'll launch the sample video, and this one happens to be object detection and pose estimation that's running. So let's go ahead and stop that, and I'll turn it over to Heath.
All right. Hey, everyone. It's been a while since you've seen my face, but David, Ali, thank you so much for going through that. I have just a hopefully a short live demo. Hopefully you can hear me okay, and hopefully the demo gods are in my favor today. But I will go ahead and start showing that off. If I can do this really quickly.
Yeah, it's funny you say that, Heath, because I was not sure that the demo gods were going to be in my favor today, so I pre-recorded mine. But you know what? I think they were favorable. I probably could have done it live. So let's see what happens with yours.
Yeah. So I do also want to point out that this is live running on an iQ8 device. So right now on my desk, I have my iQ9 EVK. And then on the right side here, my desk, again, similar to David, you can kind of see it. I don't want to pull too hard on the device itself because the cable's plugged in. But I have a webcam, just a USB webcam running through an OTG attachment into one of the USB-C ports on my iQ8. And hopefully what you're seeing is a couple things. The main thing being this facial landmark detection screen. So this is a web server, a fast API web server that's running directly on my iQ8 device that I'm just plugged into in my web browser. And what I'm showing here is we've got just the one facial landmark recognition model with all three model runtimes available, as well as all three kind of backends available as well. And it's really easy to, switch to, a TF Lite running on the NPU. And you can see how live on the device, how quickly it changes, but also how the different runtimes and different backends impact the speed or inference at which this model can run. I can also show off the QAIRT demo or the QAIRT or QNN backend. So this specific model was pulled from AI Hub that both Ali and David talked about earlier. So I just went in and downloaded and then wrote some wrapper code around it to have it inference directly on my device. So it's really the idea here is to show kind of the performance impacts and on inference times for these different AI models. But also at the same time, I can switch over to my GenAI demo. And here is just a demo of GenX, which Ali pointed out earlier, running kind of two things. First being a Qualcomm optimized LLM from AI Hub running on the backend or on the NPU backend. So I can ask a question like, walk me through how an LLM works. And I can hit send. And what's happening on this side is I've got this browser chat window. There's a fast API WebSocket that goes through to the GenX server. So very similar to like llama.cpp, there's a GenX server where I'm serving the model over a port. And then based on the compute backend that I've chosen, we'll serve that model based on the backend. So here, like I said, I'm using an optimized NPU model, getting around 14 tokens per second. I'll go ahead and restart the chat. It'll keep running in the background. That was maybe the wrong prompt to use. It's probably pretty long, verbose output here. But then I have, a couple different models here as well. So I have a, Qwen 3 1.7 billion, that GGUF model. And with this, I can actually switch between the GPU, CPU, and NPU backends and ask a similar question. Like let's try, on GPU, I can ask, why is the sky blue? And send that. And it looks like it's still tapped into the previous query that I just did. So I didn't build in a proper stop function here, but the idea here is that to show how through GenX, I can run both a community, GGUF model direct from, Hugging Face or a fine-tuned model that you make yourself, or I can run a optimized model from AI Hub or an optimized model that you've brought to AI Hub for optimization and bring it back down. That is the demo here. So yeah, David or Ali, are there any questions or anything I can show off here?
No, I think I'm good for the moment. Ali, any questions from you?
No, this was very good. And yeah, the demo gods were good with you.
Yeah, nice work. 35 frames per second. I like the application you put together. All right. Well, Ali, do you have any closing remarks? I was monitoring questions throughout. I think we got most of them answered. I don't see any that were remaining. Is there any others that you had noticed come in?
I want to touch on a few things that I saw in the questions.
Okay.
Of course, like we're building all of this out for the developer ecosystem, and there's a lot of refreshes that are happening to our documentation, as well as on each of these components. So from an AI Hub perspective, from QAIRT tools perspective, from IMSDK, GenX. So you'll be seeing a lot more content and a refresh on the existing content. So I just want to give that message to our developers out there. And the devices themselves are quite capable, and we're really working on bringing that capability out so that you can leverage it into your end project. So hopefully, as we get into additional discussions, into the deeper dives, and you see these refreshes on the content and the documentation, a lot of it will become clearer and easier to use. But we're always open to your feedback on improvements. So please do provide that through the Discord channels, through joining us on these live streams, and observing what we can show and giving us ideas of what you'd like to see in the future as well.
Yep, absolutely. Heath and I are responsible, well, along with the other folks on our team, not just Heath and I, everyone else as well. But yeah, we do quite a bit of documentation. So we are absolutely continuing to iterate, continuing to improve. You saw on my demo and the video that got played, dragonwingdocs.qualcomm.com. And there you go, right on screen. And then IMSDK docs.qualcomm.com for that one. But like I said, we'll deep dive that in 2 weeks' time. GenX, of course, their documentation is linked. I don't know the URL off the top of my head, but it's linked from the top of the navigation on their site. And theirs is very simple and easy to follow as well. So anything else, Ollie? Otherwise, we can,
I think we're good.
Close it down. All right. Well, thank you, everyone. I appreciate you taking the time to join us today. I know that we covered a lot of ground. Like we said at the beginning, this was that high-level overview of all of the frameworks and tools, utilities, architecture, and software. We will start to carve this up into smaller, more dedicated topics in the coming weeks. So definitely make sure that you are subscribed and liking and clicking any bells on whatever platform you're on. I think that should about do it for today, though. Thank you all again for joining, and we will see you in the next one.
Thank you.
Yep. Bye all.